Yesterday ended with light guiding strangers. Stairwells glowed from both ends. Exit signs burned red. Emergency lights stood ready. Harris said, "Wire for people, not yourself. They walk under your circuits without knowing your name. Respect them, or their ghosts will." Today he brought us to the service panel, where green and bare copper wires spread like roots of a tree. "Now," he said, "we build the path that saves everything else grounding and bonding." The workshop was quiet, except for the hum of the main panel. Harris tapped the ground bar with his screwdriver. "This is the heart of grounding. Every conductor here is a safety path. Without it, the breaker waits. With it, the breaker trips before a man dies." Maria bent close to a green screw inside the panel. "So this one bonds neutral to ground?" "In the main panel, yes," Harris said. "In subpanels, never. Neutral and ground meet only at one place. Bond them wrong and stray current flows across pipes, conduits, even desk frames. Touch two at once, your body becomes the jumper." He made me hold a bonding jumper-thick copper, heavy. "Why connect metal together?" "To eliminate potential difference," I said. "If two pieces of steel aren't bonded, one could carry stray voltage while the other doesn't. Touch both, and your body equalizes them." "Correct," Harris said. "Bonding is not optional. Bonding is law." He led us outside where two copper rods stuck out of soil, their tops scarred from hammer blows. Heavy copper tied them back to the panel. "One rod is not always enough. Soil resistance too high. You add a second rod. Or a U for ground in concrete." Maria kicked the dirt. "How do we know it's good enough?" "With a ground resistance tester," Harris said, showing the meter. "Code says 25 ohms or less. Hospitals demand 5 or less, because sick people cannot run." He told us about Ruiz, a contractor who trusted one corroded rod in dry soil. Breaker tripped late. Arc ran along metal siding. By the time it cleared, fire chewed half the barn. Ground was a lie that day. Never trust soil, measure it. Back inside, we saw a clamp on a water pipe. Harris pointed. "Yes, metallic water pipe can serve as electrode, but pipes corrode. People replace them with plastic. Never trust pipe alone. Always add supplemental electrode." We practiced. Maria tightened a ground clamp until the copper bit the pipe. Harris stopped her. "To tight cracks pipe, to loose makes lie. Torque matters here too." He gave us a quiz as we worked. "What color is ground, green or bare copper? Where do neutral and ground bond? Main service panel only. What if they bond in a sub-panel? Stray current? Hazard? What tool measures ground resistance? Ground resistance tester? What's the maximum OEMs? 25? And what's a bonding jumper? A conductor tying metal parts to equal potential." Harris nodded, but his eyes stayed sharp. "Loose ground is no ground at all. Tighten. Protect against corrosion. Verify continuity. Expectors fail jobs for one bad clamp." Older John's voice. Years later, I opened a panel in a warehouse. Green wires everywhere, but half the clamps loose, corroded white. A worker had been shocked, touching a ladder against a pipe. Breaker never saw the fault. I remembered Harris's words. "Loose ground is no ground," by dusk. We had driven rods, tightened clamps, landed grounds on the bar, separated neutral and ground in the sub-panel, checked continuity with a multimeter, marked bonding screws green. Harris gathered us one last time. Lesson 1. Grounding is the safe path to Earth. Lesson 2. Bonding makes all metal equal. Lesson 3. Loose ground is no ground at all. Respect clamps, rods, screws, and soil. Invisible work saves visible lives. Maria slumped onto a spool of copper, wiping sweat. "So tomorrow, more dirt and rods? No?" Harris said. "Tomorrow we test the system under lightning and surge. Tomorrow you learn grounding is not just safety, it's survival when the sky itself attacks." I looked at the copper rods outside, silent in the soil. For the first time, I understood that safety isn't in the glow of lamps or the hum of machines. It begins in silence, buried under our feet. Coming up next, episode 29. When lightning strikes, when surge arrives. Yesterday ended with copper rods driven deep into the earth, clamps tightened, bonding jumpers installed. Harris said loose ground is no ground at all. Invisible work saves visible lives. Today he raised his hand toward the sky and said, now we fight lightning. Now we fight the surge. The sky strikes without warning. If your path to earth is weak, fire runs through walls, appliances, even people, and no breaker moves fast enough. The morning was already heavy with clouds, where Harris rolled in a cart stacked with surge protective devices, panel-mounted SPD units, plug-in strips, even a meter-based surge protector. He set a length of cable scorched black in the middle of the bench. This cable was from a house after a lightning strike, he said. No surge protection. Strike entered on service conductors, traveled into a refrigerator. The man inside thought he was safe in his kitchen. His kitchen disagreed. Maria's voice dropped. So lightning doesn't just hit roofs. No, Harris said. It enters where it wants, service conductors, phone lines, cokes, even water pipes. Your job is to give it the fastest, straightest path to ground. Not a loop, not a long detour. Straight down, short, bonded tight, he mounted an SPD on the demo panel. What do we connect first? Ground, I said. Correct. Surge without ground is nothing. Hot and neutral tie-in, but ground carries the fight. Always land ground first, shortest conductor, no sharp bends. Lightning laughs at your 90-degree turns. It jumps air instead. Maria leaned close to the SPD. So these little boxes stop lightning? No, they redirect it, Harris said. They bleed it to earth faster than it can burn your wires. But only if ground is true. He gave us a quiz on the spot. What does SPD stand for? Surge protective device? What do they protect against? Transient overvoltages, lightning, utility switching, equipment faults. What is the first rule of SPD installation? Shortest, straightest ground connection. What happens if you use long leads? Inductance slows response. Surge finds another path through people. We wired the unit. Hot to breaker, neutral to neutral bar, green to ground bar. Harris measured the lead length with a tape. 6 inches, acceptable. 12. Fail. Inspectors know lightning doesn't negotiate. He told us about a data center. Everything bonded. Ground grid under concrete. SPDs on every panel. Lightning struck. Lights flickered. Servers stayed alive. Because ground was straight and SPD took the hit, they spent $5,000 on protection. Saved $5 million in equipment. Then he told another story. Darker. Small office. Cheap strips at desks. No panel SPD. Strike came in on service. Strips smoked. Panels arced. Building dark in 1 second. Insurance called it act of God. I call it act of negligence. We set up scenarios. Harris plugged a drill into a strip with no ground. It buzzed weakly, then sparked when he tugged the cord. Why? Because SPD cannot work without ground, I answered. Correct. Ground is the bloodline. Without it, protection is a lie. Maria asked, what about bonding with phone and cable? Always bond them to the same grounding electrode system, Harris said. If you don't, lightning raises one system above the other. Touch both spark through your chest. Equal potential saves lives. He showed us a water pipe clamp bonded to ground. Why? Because lightning will travel pipes too, I said. Bond keeps all metal equal. Correct. Lightning seeks difference. Bond erases difference. We rehearsed until the words became rhythm. Bond neutral to ground only at main. Bond all systems power. Phone, cable, water together. Install SPDs at service panels, point of use, shortest leads, straight runs, tight clamps. Lightning doesn't ask, it takes, older John's voice. Years later, I saw a farm after a summer storm. The barn's steel roof carried the strike. The only path to earth was a corroded clamp. Lightning jumped to the milking equipment. Cows lay still in rows. The farmer's eyes told me what negligence costs. I remembered Harris's words. Bond everything, or watch life pay. By dusk, the panel gleamed with its new SPD, leads neat and short, clamps tight. Harris gathered us. Its eyes were darker than the clouds outside. Lesson 1. Lightning doesn't stop. It only redirects. Lesson 2. Surge protection is only as good as its ground. Lesson 3. Bond every system, erase every difference. Do it, and lightning passes harmless into soil. Fail, and it burns what you swore to protect. Maria whispered. So tomorrow we fight the sky again? No, Harris said. Tomorrow we fight hidden faults. Stray currents that crawl on pipes, bolts, and frames. They don't come with thunder, they come with silence. And silence kills slower, but it still kills. I looked at the panel, SPD glowing with a small green light. For the first time I understood that the fight wasn't only with wires and lamps, it was with the sky itself. Coming next, episode 30. Stray currents, silent killers. Yesterday ended under a sky that wanted to kill us. We learned that surge protection does not stop lightning. It redirects it, and only the shortest, straightest ground makes that promise true. Harris said bond everything or watch life pay. Today he whispered a worse threat, the current that does not arrive with thunder. The one that crawls along pipes, handrails, scaffolds, and frames without a sound. The shop was quiet in a way that made me uneasy. On the bench, clamp meter, multimeter, continuity tester, a spool of green bonding jumpers with lugs, star washers, antioxidant compound for aluminum. A box of ground screws painted the exact shade of warning. Harris stood beside the service panel and the sub-panel mock-up. He tapped the main bonding jumper with his screwdriver. Only here, he said. Neutral and ground meet only here. Everywhere else they travel side by side but never touch. Bond them wrong and a sub-panel and stray current takes field trips on everything metal. Touch two different metals. Your body becomes the jumper. Maria frowned at the sub-panel.
So the bear and the white go together in the big one, but stay divorced everywhere else. Divorced with a restraining order, Harris said. Now, prove it. Pull the dead fronts. In the main, the neutral bar and ground bar were bonded with a green screw and strap. In the sub-panel, the green screw was in a bag, not in the bar.
The neutrals were isolated on an insulated bar. Grounds landed on a bonded bar tied to the metal can. Made us wring out continuity. Panel can to ground bar to equipment ground conductor, but never to the neutral bar. Continuity here, no continuity there. Say what you see. Said it until it tasted like copper. Continuity to ground, isolation to neutral. Main bonds once, subs never. He rolled the mock-up scaffold into place, a cube of steel tubes with wooden planks on top. He clipped a bonding jumper from the scaffold to the building steel and asked why. Equal potential, I said. If a fault energizes the conduit or a cord jacket fails against a tube, the scaffold must be at the same electrical potential as the rest of the bonded metal. So a worker's hands and feet are not at two different voltages. Bonding makes the shock path go home through copper, not through a spine. He nodded once. Then he told us about a painter who felt a tingle every time he grabbed a scaffold upright. No one believed him until a rainstorm turned the tingle into a kick. A loose lock nut on an EMT connector had left a raceway floating. A temporary cord rubbed through and kissed that floating metal. The current looked for a path. It chose the man. The foreman stuck his head in to borrow the clamp meter, then stayed when he saw the scaffold. He told a story from a winter a few years back. A trailer office hummed with portable heaters and printers. Someone bootlegged a neutral to a ground pin and a cheater plug to stop a trip. The trailer frame became part of the return path. A delivery driver leaned on the metal threshold with a wet sleeve and learned a language he didn't want. They shut the site for 2 days, then ripped every cord, every plug, every bootleg out of the trailers. The foreman's voice turned flat at the end. Never cheat the ground. It cheats back. We spent an hour as Lee hunters for stray current. Clamp meter jaws around water pipes, around cable shields, around equipment grounding conductors. When the reading showed anything but noise, we found the reason. A neutral landed under the wrong screw. A bonding bushing missing on a rigid entry. Painted hinge used as a return. A steel door frame not tied to the building steel. Each time Harris asked the same questions. Where should the bond be? At the shortest path to the grounding electrode system? Or to the equipment grounding conductor system? Why there? Low impedance. Short run. Few joints. How do you ensure metal to metal under paint? Scrape, star washer, listed lug, torque. What do you write when you're done? Location, conductor size, termination type, torque, test reading. Maria stuck her finger under a handrail that ran along the mock stair and felt a sting. She jerked back. Harris had set the handrail on plastic isolators. It looked like steel, felt like steel, but it floated electrically. A nicked conductor in a nearby box had brushed a mud ring and made the faceplate, just loud enough to whisper through the rail standoffs. Without a bond, the rail kept its own tiny weather. We landed a jumper from rail to building steel, tightened, retested. The sting vanished. She looked at him like he had pulled a splinter from her pride. He only said, "Make every metal part pick a side."
Hours.
He told us about a supermarket cooler line years ago. A refrigeration contractor had hung a shiny run of copper tube, beautiful curves, no bond. A motor shorted later energized the tube. A stalker reached in for a tray of lettuce and met a better path to earth. The breaker did not see enough fault through tile and shoes. They found the problem by the humid prints on the glass. One green jumper would have made the breaker faster than tragedy. Mid-afternoon, he made us stop and look back at the last 2 days. Because this was the third episode of the lesson, and the lesson demanded a knot tied tight. Day 1, we drove rods, landed bars, kept neutral, and ground loyal to their places. Bonded water pipes and structural steel, checked resistance, learned that loose ground is no ground at all. Day 2, we fought the sky, learned that surge protection is only as honest as its ground, and that all systems must be tied to one heartbeat, so lightning does not find a chest to cross. Today, we hunted the silence between those 2 days, the little voltages that take their time, the faults that wait for rain, the frames that wait for a hand. He pushed a gas pipe mock-up toward us. "Bond it," he said. "Shh, not to make it a conductor, but to keep it from becoming a better one in a fault. Use a listed clamp. Keep it close to the service entry. Do not depend on a flexible connector to carry anything. If the pipe is corrugated stainless steel, follow the manufacturer's bonding instruction like scripture. Tiny arcs on corrugations can write long fires. Quiz again, faster this time. Where do you bond neutral and ground? Service disconnect once. What happens if you bond them again downstream? It's parallel neutral current on equipment grounds. Tingle voltage on metal. How do you reduce touch potential on an area of wet concrete where workers stand? Equipotential bonding grid or mat tied into the system. What does a clamp meter on a grounding conductor tell you during normal operation? Ideally near zero. Current here means a mistake somewhere else. Where do stray currents like to hide? On long painted hinges, unlabeled door frames, isolated rails, unbonded equipment, bootleg neutrals, flexible gas connectors, shield drains, scaffold joints. What is the cure? Bond, scrape, star wash, tighten, test, document. He gave us one last scenario with a portable welder on a steel mezzanine. The return clamp was attached to a painted beam. The arc wandered and burned paths in places it didn't belong. We cleaned the beam to bare metal, bonded the mezzanine to building steel, routed the welder, returned properly. The machine stopped trying to write its signature on the building. He made us say the principle out loud. Currents will take every path you give them. Give them exactly one, a copper one. The sun dropped, and the room turned golden. Harris stood between the panels and the scaffold, between the pipes and the rails, like a man keeping the peace at a noisy market. He didn't raise his voice. Lesson 1, grounding makes a safe path home for faults. Lesson 2, bonding makes all metal equal, so your body is never the path. Lesson 3, stray current is silence. You must hunt it with eyes, jaws, and rules. If you are lazy with green wires and clamps, every other lesson dies with them. Maria sat on the lowest plank of the scaffold and rubbed her arms where the earlier sting had surprised her. So this is the part no one posts in photos. He almost smiled. The prettiest work doesn't show, he said. Best work never makes a sound. We killed power, tagged the panels, wrote down the measurements and torque values, and coiled the green jumpers with care. I looked at the scaffold and the shiny handrail with its new bond, and felt the odd pride of having made nothing happen. No tingle, no hum, no whisper, just metal that now agreed with itself. Coming up next, episode 31, The Temporary City, Power That Moves and Fails.